Okay, what is clothesline system? A clothesline is a device used for drying clothes by hanging them in the open air. However, the regular clothesline cannot move to the covered area by its own if no one is at home. Automatic clothesline system makes things easier and to improve the system of clothes drying system in a modern way. So, the target of this project is to reduce or eliminate the effort of pulling, hanging and retracting the clothesline. It can save space in home, especially where the outdoor area are limited, and this project aims to reduce time and labor involved in hanging clothes.
As is objective. First, to develop an automatic clothesline system that is automatic and more convenient, efficient and practical for everyday use. Second is to evaluate the effectiveness of the system in keeping clothes dry during rains and increase the convenience of using. The last one is to establish weather-based mechanism that will react fast without manual intervention. Now, we move on to the digital collaboration, which is WhatsApp. WhatsApp is using as our main platform. Group chats, video message, and video calls help us communicate in real time. We also share documents, photo, and video directly in the group. Pin and star message help us keep track of important information. We delegate tasks, set deadline, and monitor progress through message. Mention and post help us make group decisions quickly. Overall, WhatsApp helps us work efficiently and keeps the workflow smooth through the project. Next is YouTube. YouTube helps us to learn how to design and implement an automatic clothesline system. We watch tutorials, instructional video, and demonstration. We also learn the concept, mechanism, and real-life example of the system. This helps us make a better decision and improve the quality of our project. We also use Arduino IDE in our system to create, edit, and upload code to the Arduino board. It allows us to control sensor, motor, and other hardware components. Arduino IDE helps us automate the clothesline system. We use it to test the system function and also make sure it will work well when developed.
Now, I will introduce you to our project management team. The first one is project manager, that is AISYA SABRIENA binti Muhammad SOBERI. And then our software manager is ARISSA SUFINA binti RIZAL. And then our designer engineer is FAIZATUL binti ISMAIL. For electrical engineer is NORASYIKIN binti IMRAN. And our documentation engineer is ZULAIKHA binti SHAHRUL.
Next, we move on to the components used in this project. This is the Arduino Nano, a compact microcontroller that acts as the main control unit of our automatic clothesline system. Its function is to process input from sensors such as the rain sensors and the control output devices like the servo motor. In short, the Arduino Nano is the brain of the system, enabling the clothesline to operate automatically without manual intervention. For this part of the project, we use a USB 2.0 Type A to Mini B cable. It connects the system to a computer for power supply, programming, and data monitoring. Next is the rain sensor. It detects rain or moisture using a conductive plate. When water is present, a signal is sent to the system. With both analog and digital outputs, it allows the clothesline to respond automatically when it's rain.
Okay, next is serving motor CJ90 180 degree that is capable of rotating 180 degree. It's suitable for beginners and it has 3 horns and mounting hardware. It also can control using standard servo codes and suitable for complex applications. Next is mini breadboard. It's used to quickly build and test electronic circuits commonly used in Arduino project without soldering required. It has holes for components include power and ground rails. It's also ideal for space constrained or portable project. It's also allowed easy connections, disconnections, and reuse of components. So this is the jumper male to male. It has male pin connectors on both ends and it used for temporary electrical connections. It's also useful for phototyping on breadboard and Arduino project. It's essentials for building circuits, testing connections, and making modifications quickly. It's also available in various length and colors. It's allowed easy solderless linking of components.
Next is jumper female to male. It is used for electronic prototyping. A female socket on the end accepts a male pin, and a male pin to other end to plug into a female header or breadboard coil. It is reusable wire, allow components like microcontroller, Arduino, and sensors without soldering. And lastly, power bank. It is portable battery used to supply stable power to electronic components and microcontrollers like Arduino Nano. It allows the system to operate independently of main electricity, and it is provide reliable voltage and current, ensuring the continuous operations.
For this slide, I will explain how the Arduino Nano works as the main controller of our system. First, we include the servo library because our system uses a servo motor to control the clothesline movement. Then we define the pin configuration where the rain sensor is connected to analog pin A0. And the servo motor is connected to digital pin 9. Next, we set a threshold value to determine whether rain is detected. If the sensor reading is lower than this threshold, it indicates that the rain is present. In the setup function, the Arduino starts serial communication and sets the servo motor to its default position, which is the closed position, to ensure the system starts in a stable condition. In loop function, Arduino continuously reads the rain sensor value and compares it with the threshold. When rain is detected, the servo motor moves to 0 degrees, which closes the clothesline to protect the clothes. When no rain is detected, the servo motor moves back to 90 degrees, allowing the clothesline to remain open. This logic allows the system to automatically respond to changing weather conditions without manual control. For this slide, I will explain the function used to control smooth servo movement. Instead of moving the servo motor suddenly, we created a custom function called Move Servo Smoothly. This function allows the servo to move gradually from the current angle to the target angle. First, the function determines the direction of movement. Then, a for loop is used to move the servo 1 degree at a time. A small delay is added between each step to ensure smoother movement. This approach helps to reduce possible damage to the servo motor or the clothesline system. The current angle is updated after every movement so that the system always knows the latest servo position. Overall, this function improves the stability and durability of the system. Next, I will explain about the project overview. This slide shows the component setup and our project final model. I will explain a bit for the circuit diagram. As you can see on the diagram, the rain sensor is connected to the Arduino's power, ground, and signal pin to send input data. Meanwhile, servo motor is connected to the Arduino using power, ground, and a digital control pin. So, Arduino processes the sensor input and sends a signal to the servo motor to perform movement. Therefore, all components share a common power and ground connection. Now I will be discussing about our project. This automatic clothesline system is designed to protect laundry during unexpected rain. Using an Arduino Nano as the main controller, the system continuously monitors the environment through a rain sensor. When rainfall is detected, the microcontroller activates a servo motor to retract the clothesline under the roof. This automatic response prevents clothes from getting wet and reduces the need for constant user monitoring. Overall, the project demonstrates how low-cost components and basic sensor technology can effectively solve everyday household problems, with potential for future smart home integration.
In conclusion, the automatic clothesline system provides a simple and effective solution to protect clothes from unexpected rain. By using a rain sensor, Arduino Nano, and servo motor, the system operates automatically by rotating the clothesline when rain is detected. This improves daily convenience and reduces the need for constant monitoring. For recommendation, we suggest integrating a timer-based control system and an automatic drying function during rain. The timer system allows the clothesline to operate at scheduled intervals, saving energy and reducing unnecessary motor use. The automatic drying function ensures clothes dry quickly when it's rain, improving convenience and reducing manual effort.